So anyway, this is exercise 1C.1 kind of continues. So this is we're going to end up with 3 parts of this, I think. I'm going to quickly finish this. There's only, I had a quick look and there wasn't much left. So I've just tidied up my mess here. This was all a bit messier just now, but I just want to explain. So what I was trying to say is that if I'm adding in all the terms, start at the nth plus 1th term going up to the 2nth term, I want you to imagine a bunch of numbers going across 1, 2, 3, 4, 5. Eventually you're going to get up to what we're going to call the nth term. And the one after that is the nth plus 1th term. And eventually if you keep going, you'll get to a number which is double this number, which is the 2nth term. And that's the number which we've got to stop. But actually it only wants these terms. It says start at the nth plus 1th term and go up to the 2nth term. Now what I did here was I said, well, let r equals n plus 1 to 2n. And this is right. The problem with this approach is we haven't got any formulas for any of these summations which start at n plus 1. And so that's why, although this is technically right, and what I did, get rid of that, it says r squared. Although technically right, it doesn't help you because we haven't got a formula for this. So it is much better if we start at r equal 1 every time. Now, in order to do this, we're saying to go from 1 to 2n, we can add all of those numbers up. But then we've got too many, and we then have to take away these ones. And this is what this represents. So this says add up all the numbers from 1 to 2n. But then you better take away the numbers we don't want, and that's the numbers from 1 to n. Because we only want the numbers from n plus 1 up to 2n. So that's where that formula comes from. And that's what I was saying to you just now on the other video. Just now for me, I'm not sure if it was for you. That really should say r squared there. And I'll know that's right if in a bit, when this comes up, I get this formula. So let's just see if I can manage to do it. So hence find the sum of this. So we're saying the sum of all of these is really equal the sum of all the r squareds from 1 to 2n. Now we've got, if I just write this out, this is r equals 1 to 2n of the r squareds minus the sum from 1 to n of the r squareds. Now we've got a formula for the r squareds. It's a sixth of n plus 1 to n plus 1. But of course, I am going up here to 2n. So where is my formula as a sixth of n plus 1 to n plus 1? Which is, the right formula. Because I'm not going up to n, I'm going up to 2n, I have to adjust it. And by adjusting it, I just change my n to my n term, which is 2n. I then times it by, it's normally n plus 1, so mine will be 2n plus 1. And it's normally, I normally double the n and add 1. So here I double the 2n and add 1. So it's just a bit weirder. And then I subtract the standard 1 to n of r squared, which that's a standard, and n plus 1 to n plus 1. And then I'll look for things that go into both terms. We'll both say a sixth, that made it easy. Both say 2n plus 1. 2n plus 1, 2n plus, and both say n, n. So I can take out an n and a 2n plus 1. And then I would put a square bracket here. What have I got? I've got, so that and that has gone. So I've got 2 lots of 4n plus 1. So I might as well call that 8n plus 2. Then I just times out those brackets. Minus, I've lost that. I've just got an n plus 1. I better be a bit careful. Minus the n and effectively minus a 1 as well. So this is a sixth of n, 2n plus 1. And what's this give me? This gives me 7n plus 1. Ah, that's lucky, because that's what it says. So all that is right. And I've got one final example, because they don't always start at 1. And so here's, well, we saw just now that that one didn't start at 1, and we had to adjust it. We had to make it start at 1. So here's an alternative way of doing it for this example. And it says from r equals 0 to n. So really so again, if I draw my number line, normally I go from 1 to 2 to 3, ... and eventually I get up to my nth term. On this particular occasion, I want to start at 0, which is fine. That's what the one I've got a formula for. I've got formulas for that. So I just have to add on this term. So I can think of this as the sum from r equals 1 to n of 3r squared plus 5. But then I have to put, well, really I just have to put naught into this expression. I missed out that term. I missed off this term. So I'm going to go plus 3 times naught squared. And this has a value. So I could just add it on at the end. So this equals, well, this is 3 lots of r squared plus summation of the 5s. Summation of the 5 is probably better off thought of, I'm going to cross that out, as 5 lots of the summation of the 1s, because you can see 5 1s are 5. So even though I've not written r equals 1 to n, r equals 1 to n, and then we've got to add on that extra term. Now what does this term give me? 3 lots of naught squared is 0 plus 5 plus just plus 5. That's just a normal 5, that's just the value of that. So we've got a formula for this. It's 3 lots, and we've got that formula again. I've learned it now. It's coming back to me. A sixth of n plus 1, 2n plus 1. Plus. Now I did give you a formula for this. I just said if you add up all the 1s, you get n. So this is just plus 5n from the 5 there. And don't forget the 5 at the end. So let's tidy this up. I get a half, 3/6 of n plus 1, 2n plus 1. And the reason why I quite like this is, notice this actually factorizes, does it? 5 lots of n plus 1. And so remember, we always try to join these things together. So I'm going to take out a half as a common factor. And I've got an n plus 1. Not much else, in all honesty. And then I've got, well, I can just times it together. I've got a 2n squared plus an n. And if I take out a half of n plus 1, I just reckon it's plus 10. Because there are 10 halves make 5. And everything else sorts itself out. Well, that's the worst bracket ever, that. So anyway, what does that factorize to? Does it factorize? Let's check the answer. No, it doesn't. It didn't look as if it did. There you go. There's my answer. And I just want you to have a go at all, not all of these, some of these. So we're going to do more of these next Wednesday. So you don't have to worry too much about it. Do a few, get up to a point you're comfortable with. The homework won't come until after you've done the second PowerPoint. So all the best, and I'll speak to you soon.